Hey everybody, Chris McClure here. Now we're going to talk about circles. Yesterday we talked about lines, graphs of linear equations. Now we have circles. And the important thing to understand is that a circle is the graph of a two-variable equation, but it's also a collection of points on the xy plane that are equidistant from a given point. And that distance, of course, is the radius of the circle. Okay, so we're going to start off by first looking at the so-called standard form of the equation of a circle. Now, here's kind of the concept here. We have some point on the xy plane with coordinates h comma k. X coordinate is h and the y coordinate is k. And then think about that fixed distance from the point. Let that distance be r. R as in radius. So we have a point, h comma k, at the so-called center, and we have a radius r. And what we want to do is say that the distance between the center, h comma k, and any point on the circle itself is going to be constant r. And you know what the distance formula is between h comma k and x comma y. And that distance formula is the inspiration for this equation. Remember, the distance between x comma y and h comma k is going to be the square root of x minus 8 squared plus y minus k squared, and that distance would be r. So when you square both sides, you have this equation. And this equation right here is the standard form of an equation of a circle. That is centered at h for the x-coordinate and k for the y-coordinate, and radius r here squared. Okay? Now the simplest circle would be one that is just centered at the origin, with h and k both being 0, with a certain radius r. And if r happens to be 1, what we call the unit circle, then the right side would just be 1. The unit circle is like a very basic, probably the most basic circle that we have. It's centered at the origin, has a radius 1. And for those of you going on to trigonometry, you will have a lot of experience with a unit circle. But we want to talk about circles in general that are centered anywhere on the plane and that have any radius. So all we need to do, though, is just use this equation here for the standard form, and then if we know the coordinates of the center, like in this example here, then we plug the x-coordinate of that center point in for h, and that y-coordinate in for k, which is -4, and then we'll plug in 4, which is the radius, in for r, and then see what we've got now. So here in our next step, we plugged in 2 for h and -4 for y. Y minus -4 is y plus 4. And on the right side, we had radius 4 squared, which is 16. And so there, this equation right here is the equation of a circle centered at 2 comma -4 with a radius of 4. Okay, let's talk about graphing a circle. How do we do it? Well, we could be given the equation in standard form, like you see here. When we could tell just by looking at this number here and this number here that the coordinates of the center point are 4, comma -1. You see the y plus 1? Think about that y plus 1 as y minus -1. So we see the coordinates of the center point is 4 comma -1 with radius 3, because 9 is 3 squared. Okay? So there's our center, there's our radius. And then on the xy plane, we locate that center point, 4 comma negative 1. And then, hey, we could use a compass if we have our pencil and paper out, and we stick the little pointy end right there, and then we stick the leaded end or part of the compass somewhere 3 units out. Of course, we'll have to adjust the compass, and then we just twirl the compass around so that we have a circle of radius 3 all the way around. Every point on that circle had the same distance from the center. Okay, so now let's talk about intercepts. Remember what intercepts were? Intercepts are the locations where your graph crosses the x-axis and the y-axis. Same concept applies here. If you want to find the x-intercept, then you set y equal to 0, which we're doing for this equation here. Same equation. Plug 0 in for y. So you have x minus 4 squared plus 1 squared, which is 1, equals 9. And then you subtract 1 from both sides. So now you have x minus 4 squared is equal to 8. And then take square roots of both sides. That means x minus 4 is a plus or minus square root of 8, which is plus or minus 2 root 2. And then solve for x by adding 4 to both sides, so that you now have x is equal to 4 plus 2 times the square root of 2, and 4 minus 2 times the square root of 2. So those two x values will give the x intercepts. Now, if you take 4 plus 2 root 2, that gives you a decimal of about 6.83, which is this point right there on the graph. And if you take 4 minus 2 root 2, you get a decimal of approximately 1.17, which is this point right here. Now, notice that there aren't any y-intercepts. And you can just understand that by, look, if you were to set x equal to 0, you'd have 4 squared here. And 9 minus 16 is a negative number, right? And we can't have anything squared being equal to a negative number. So that's why we don't have any y-intercepts for this graph. Okay? All right. So I'm moving along here. Now, we earlier saw the standard equation. Don't get the standard equation mixed up with the general form of the equation of a circle. Here's the general form. When you have it basically to where everything is kind of all expanded out and moved over to the left-hand side of the equation, and you have an equal 0 on the right side, then you have the equation in general form. This equation right here is in general form. So in order for us to graph this, we still need to know the radius and the center point. So we need to do a little bit of algebra to do that. So we need to get the x terms together and get the y terms together, and maybe take this minus 5 here and add 5 to both sides that we see here. Now, you see that we've got these little spaces right there, because we're going to complete the square. Remember how to complete the square? You see the coefficient for the single power of x term, the linear term. Take half of the negative 8, which is negative 4, square it, so that you got 16 right there. You'll add 16, which means that you'll also add 16 to the right-hand side. Something similar for the y's. You take half of the 4 there, which is 2, square, you get 4, so you'll add 4 to both sides of the equation. So that we have now written perfect squares of these binomials on the left-hand side. And of course, on the right-hand side, we can add these 3 numbers to get 25. The x squared minus 8x plus 16, that's x minus 4 squared. The y squared plus 4y plus 4, That is y plus 2 squared. So now looking at this equation, we can quickly pick out the coordinates of the center point. It's going to be 4, comma, negative 2 with a radius of 5 because 25 is 5 squared. Okay? So let's just review what we did. We were given this equation here, which is the equation of a circle. How do we know it's the equation of a circle? Because you see an x squared term there and a y squared term there. That's a dead giveaway that you're dealing with the circle. So then all you need to do is rearrange the terms. So you got the x terms together, you got the y terms together, move this constant term to the right hand side, complete the square for both the x terms and the y terms, and then factor as complete squares, and then you can quickly recognize your circle's equation in standard form, and then you can read off the center and the radius. Okay, here we go. We're going to graph it now, plot the point 4, comma, negative 2, and then pull out your compass and set it for 5 units for the width of it, and then go ahead and draw that circle, which is the collection of points on the plane, 5 units away from that center point. So now let's talk about graphing. How do we do it on our graphing calculators? Well, in order for us to graph any equation, we need to be able to express it where you have y written as a function of x. Well, we'll talk about functions later, but you need to be able to isolate y. Well, when you do that here, and you subtract x squared and take square roots of both sides, you'll have both y is equal to square root of 4 minus x squared and y equals negative square root of 4 minus x squared. Let's go ahead and do that together. Pull out your graphing calculator and I'll pull out mine. And let's take a look here. I got my graphing calculator and I still have all that stuff from yesterday, and that's good. I'm going to clear all that stuff out. Okay. So just clearing all that stuff out. As nice as it was to graph those lines, we got to do something different today. Okay, so now go back up to y sub 1. Now let me just double check. We're taking the square root of 4 minus x squared. Okay, so here's the square root symbol right there. You have to make sure that you use the second button in order to access that function. And then in parentheses, 4 minus x squared. Close parentheses. Enter. Now, we're going to put in almost exactly the same thing as for y1, but we'll put a negative. Oops. And we didn't mean to do the subtraction symbol. We need to do this negative symbol. Negative square root of parentheses 4 minus x squared. Close parentheses. Enter. Let's go ahead and set our viewing window. We know that this is a circle of radius 2 centered at the origin, so maybe we can set the x minimum to be negative 3. Enter. Oops. Let's go back up there and fix that. We meant to say negative 3. Enter. X maximum, positive 3. Enter. X scale is 1. That's good. Y minimum, negative 3. Enter. Y maximum, positive 3. Enter. And Y scale is 1. That's perfectly fine. And of course, you see the preview down here. And it looks like an oval, huh? Even though we know darn well it's a circle. So if you really want to see the perfectly shaped circle, then you can go to the zoom button and then click on option 5, which will give you the ability to make your circles look round. Okay? Alright, let's move out of there. So I just showed you how to do that. So remember, for the circle, you have to put in 2 functions of y to get the upper half and the lower half. Because in the graphing calculator, you can only graph functions, where you have y isolated to the left. Okay? So that's pretty much our discussion of circles in a nutshell. All right, we have a couple of more smaller topics to hit here in chapter 2, but we are getting close to the end of chapter 2. So you know what that means, yet another quiz, which I'll be posting later this week. So I see some of you have finished the chapter R quiz. In fact, almost all of you have. Some of you still didn't manage to get it done, and I don't know why. And I see some of you have actually done the chapter 1 quiz, and that's good. And folks, just understand, this being a summer class, we go through this material fairly quickly. We already had one student drop because he was under the impression that he was only needed to spend maybe 1 or 2 hours per week, and I don't know where he got that impression. You know, for a class like this, someone needs to expect to spend about 15 hours a week, plus or minus a couple hours, depending on how well you are already familiar with the prerequisite material. All right, so just understand that. We're going to continue on this pace for another 6 weeks at the most, 5, probably more closer to 5 weeks. All right. Another point is that when I get back from a trip, so month or a week and a half or so, so the Monday after I get back, I'm probably going to be in addition to everything else I'm doing to get back to the office, I'm going to be sending you an email, and I need a response from everybody who is taking a class. Here, hold on. Okay, I was going to turn on my webcam. Sorry. But what I need is for everyone who is going to be taking their midterm exam at a DMAC campus to tell me which campus that they're going to be doing it. So just make sure that you know which campus that you're going to be doing it at. Otherwise, if you're going to be taking your midterm exam, as well as your final for that matter, at some other location besides a DMAC campus, then you need to make sure that you send me your proctoring form from your proctor. Okay? Some of you have already done that, but I'm still waiting for a couple other people. Okay, so make sure that you're working on your testing situation as well as staying on top of your homework and reading the textbook. Okay, take care, folks, and I'll talk with you later.